And this is also one question which may seem like a difficult thing, but again I suggest the fact that you go through the basics of permutation combination, you can come to this conclusion. What they say, first we'll write down the information which is given. Non-zero digit, one non-zero digit, one vowel, one consonant. This consonant question, one question is there, I think in 2011, or sorry, not 11, 2021 or something, where they have said about, arrange the consonant, all the consonants are there. How many consonants will have this mirror reflection, or there are some consonants which will have mirror reflection. So how many are left out? Some question is there. So if you see, again, that is a point. Understand that question. Now again come to this question. You can solve this question. The meaning of consonant that you might actually very well know. In English, 26 letters are there. Okay, 26 letters are there. A-E-I-O-U. Okay, A-E-I-O-U happens to be the vowel and the consonant. So how many? This is 5. Okay, so total 26. So 5 letters are there. So 21 is left out. Very simple. And there are 3 things. Look at it. In the password, there are 3 things. There is also, 9, 8, 7, 6, 5, 4, 3, 2, 1. Non-zero. So 0 is not included. In this 3 or 3-letter password, you have a vowel, you have a consonant, you have what is called as a non-zero digit. Now you look at the basic arrangement, you will get this. This is permutation combination. Now you will get the answer. Now see here, how many? So one more thing that they say, see, in this condition is very important, right? Such that each password cut பண்ணிறேன் சரியா. இப்போ now come again to this fact that look at this, 3 letters are there. In this 3 letters you have to have the first letter being chosen from one of the 5 things. One of the 5 things you have to choose from this vowel. Next you have to the end with the consonant. The end should be one of the consonant which is there, 21, and the number 9. So 9 numbers are there, right? So this is the answer. So you just check 45 into 21, that will come to this point. So this is the basic of this. It may seem as a little difficult at first, but when you go through the questions, you will find out that we have to know what kind of vowel, consonant, and the non-zero digit. And there are also distinct questions like natural numbers, integers. You just go inside the hall with that knowledge, you will be able to solve the question. Now come to this again. This is again a question very similar, or not similar. This is something which we solved, something related to this, odd digit occupying odd numbers, odd digit occupying the odd positions, even digits occupying the even positions, something very similar to this. They have also asked something like this. There are, see, look at it. Now repetition of digits, 2 2s, 3 3s are there. How many distinct numbers can be formed? But they have this one clause. It should be greater than 30,000. It's the very, see, now you have 5 positions. Look at this. 5 numbers are there. You have to have 5 different combinations of numbers and permutations of arrangements so that they are distinct. But you already have 2 2, 3 3s. Okay. Now, one condition that they give is it should be greater than 30,000. That means this position is 3 only. It cannot be 2, because if it position starts with 2, it's not a greater number. It starts with 3. Now you have to fill in with the rest of the numbers. Now you fill in with the rest of the numbers. It can be either way, See, look at this, 4 3 2 1. Because 4 numbers are there, 2 1. So you have this 4 3 2 1. But the point is that you have to have this 2 into 2 also present. Correct? That is because That is because you have a repetition of digits. You are having this 4 into 3 into 2 into 1 as a method where you are calculating the different different positions, different numbers. But in this, there are two numbers of the same, three as the same. It's not three threes because 3 is already fixed. We are just calculating the 4 positions. I am not calculating the 5 positions. 4 positions are being calculated, and so this is the number. So this is actually very similar to the question that was asked here. So you have to choose accordingly and put the answer. Now come to this position. So here this question is a little little on the side of it is easier, but it's on the side where you may feel that it is a little difficult. But again, if you know the basics of this permutation and combination, you may arrive at the answer well. Now look at this question. Now just first you have to look. There are 3 numbers are there. Okay, they are distinct non-zero digits. Okay, not numbers, non-zero digits. Okay, ABC represent not numbers, ABC not digits. That means they are like 1 2 3 4 5 6 7 8 9, not 0 because they are saying as non-zero. Suppose x is the sum of all possible again combinations of 3-digit numbers formed by ABC. Okay, ABC can be any number, non-zero digit. It has to form a 3-digit number. So as we have seen, look at this point, 3 numbers or 3 positions. It has to have a different permutations can be there. So 9 is there, 9 into 8 into 7. This many combinations of numbers are possible. But now come to this point, without repetition. That is without repetition. If it is with repetition, means this position can be filled by 9 times, this position can be filled by 9 times. So each position, because it can be repeated, right? Here, why I am saying 9 means 9 thing can fill this position. Once this goes off, 8 things can fill. Once one more goes off, 7 things can fill. But now come to this question, it's not talking about this. The question is talking about all possible 3-digit numbers formed by ABC without repetition. Consider the following statements. The statements are: the 4-digit least value of x is 1332. X is the sum of all possible 3-digit numbers formed by ABC without repetition. In this, they are talking about an x having a sum of 1332, which is the least possible value. Least possible value, if the sum has to be there, the digits have to be a combination of the least numbers which are there. It's the very simplest fact. Look at this, x is the sum of the value of 3-digit number, and this many combination can be done without repetition. With repetition, this many are there. See, there are so many combinations of numbers as possible, but they say that the 4-digit value of x, the least 4-digit value of x is 1332. Least value of a sum can be obtained by the least values of the numbers present. Now, so it means that only these three can be used for forming the digits and their summation. Now look at it, 3 into 2 into 1. So that means there are 6 variations of 6 permutation, but that does not is the question. The question is we have to obtain the sum of all these numbers. So 6 permutations are possible. Now the numbers that you have to choose is 132. Now look at it. So if you choose 1, it can be either 2 or 3. So here here 3, here 2. If it is 2 means again it can be 1 or 3. Okay, here it can be 3, here it can be 1. Okay. Now, if it is 3 means it can be 1, it can be 2, it can be 2, it can be 3. Sorry, it can be 1. This is a method that you can adopt. See, this is 6 combinations of numbers as possible, right? How to come about is that you can have an chart where you can have one. So this is one number. Look at this. This is one number. This is one number. And this is the second, or this is the second number. Look at each number. This is the second number. Again, this is the third number. This is the third number. And then you look at it. This is the fourth number. This is the fourth number. And fifth number. Okay, fifth number. And this is the sixth number. Okay, this is the sixth number. These are the numbers and the combinations which are possible based on the clause that they have given. Now, our point is to add all these numbers. You have to add all these numbers. Now, look at it. See, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. Okay, 2, 3, 1, 3, 1, 2, 3, 2, 1. If you add, you will get this number. You will get this number as the least possible value or least possible four-digit number which is possible by the addition of the numbers formed by these things. And the next, so 1 is true. Okay, 1 is true. This is the point I'm trying to say. Then the 3-digit greatest value of x is 888. 3-digit greatest value of x, it can be formed. Greatest value means you have to form it with 987. That itself is, going above 888. This is not true. 3-digit small number that you have to least value of 4-digit number which can be formed as a summation can be from this. So greatest value means this. If it is this means how is it going to be 888? This is the answer. So this is the point that you have to now check. Now we'll go to the one more question, which is like, how many 3-digit natural numbers without repetition are there such that each digit is odd and that number is divisible by 5. So there are 3-digit odd number. See, look at this again: 4, 5, 6, 7, 8, 9. Natural numbers means it is above 0. Okay, natural numbers means above 0. And the one clause that they have given is each number is each digit is an odd number. Odd number means these are the odd numbers. Look at this. Odd means it's not going to include the 2, 4, 6, and 8. So now you have to have 3-digit natural numbers without repetition, where each digit is an odd number. One more clause is if it has to be divisible by 5, it has to be a 5. So out of the 5 numbers which can be used for the arrangement of numbers, this position has to be 5 so that this number is divisible. You cannot have any other number in this position for it to be divisible. So it has to be filled with 5 only. Now 2 more positions are left. Okay, 2 more positions are left. That 2 more positions can be filled by these numbers. It's a without repetition thing. So 2 more numbers can be filled by this. So answer is 12. So this is the basic of permutation and combination. I want you to check this question. Without this, you can use so many other questions are there. Maybe we'll solve one by one. I'm solving as the significance of the question is increasing. We have to also allocate some time for understanding this. The basic, you don't go to the formula or the difficult types of question. Go to the basics. Like, for example, look at this. On a chessboard, in how many different ways how many different ways can 6 consecutive squares be chosen in the diagonals? Okay. How many different ways can be there? If you see chessboard, so you have to know that this everyone is going to know. Chessboard will have this 8 squares, 8 into 8. So you have the 64 squares. So it's basically 8 into 8. So you have in that diagonal will be there. Diagonal is actually 8. Okay, diagonal is actually 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, diagonal is 8. In this, they say that 6 consecutive squares have to be chosen. In this 6 consecutive squares, how will you choose? Look at this. This is how you will choose. 6, you will choose like this. Then you can choose like this. Then you can choose like this. That is, you can choose from 1 to 6, you can choose 2 to 7, you can choose 3 to 8, you can choose. This is the logic of this. This is the choice. This is the combination that I have been talking about. It cannot be done any other way. If you have to choose 6 consecutive means you can trace it this way also. That's the point I'm saying. It's choosing. You can choose this way or this way, but this is the point. 1 to 6 is 1, 2 to 7 is 1, 3 to 8 is 1. So this is actually coming to the point of 3. But answer is like 6. Answer is 6 because chessboard in how many different ways can see, this is one diagonal. You will have one more diagonal here. You will have one more diagonal here where you will be choosing 6 consecutive chess boxes, and you can have 3 combinations in that as well. So it is actually 3 plus 3. This question, as I have been saying, is not that difficult. Permutation combination may appear a little difficult, but if we apply our logic a little bit and go for questions which are on the easier side, this question can be solved. Now we'll solve one more question. Consider all 3-digit numbers without repetition. Okay, not with repetition, without repetition, obtained using non-zero digits. Look at this. It's talking about the non-zero digits. Non-zero digits, as I have again put it here, non-zero means very simple. 6, 7, 8, 9, which are multiples of 3. Here, it talks about, 5, divisibility by 5. So that means 5. Here, one more clause that they included is, the digits are non-zero, but they are multiples of 3 means it can be this only. It can be this only. If it is a multiple of 3 means 3 into 1, it can be this, 3 into 2, 3 into 3. Other numbers or other digits you should not consider at all, because the digits are formed by the multiples of 3 only. Now, how many can be, so you can have 3 combinations, right? Sorry, not 3. 3 numbers, 3 into 2 into 1. So that is 6 combinations of numbers are possible. So here, what is the, let S be their sum. So how many combinations are there? 6 combinations are there. How many possibilities are there? 6 possibilities are there. So they say that sum it all and it will be divisible by 74 and 9 is what they say. Again, you apply this logic of 3, 6, 9. Okay. So the chart which I gave, the chart or the flow or the tree that we had, you can have like this 3, 6, 9, and you can have 6 and 9. Okay, 9, 6. You can have as 3 and 9. You put it as 9. You put it as 3. You can have as 3 and 6. You put it as 6, 3. Now you add all. So this is one number. Okay, this is one number. Similarly, the case, the tree which I showed in the previous question. Now you add this 6, 3, 6, 9, 3, 9, 6, 6, 3, 9, 6, 9, 3, 936, 963. You add them, okay? You add the number will come, and the number is divisible. And addition, the number which is coming, it is actually divisible by both, or it can be divided, or both 74 and 9 are factors of the sum of the number which is obtained after forming all these digits using the conditions which have been given. This factor logic also is very, very significant. It is being asked as several questions. That also you should check. Maybe we will make some other video on factors as a thing. But because see here, the factors is also or the divisibility of numbers is also forming a very important part of the question that have been asked in CSAT. Now here, look at it. How many 5-digit prime numbers? Okay. So for this, as we were talking about natural numbers. So natural numbers, I was saying like 1, 2, 3, something like that. Prime numbers. What are these prime numbers? You should see prime numbers are numbers divisible by themselves and 1. Okay, they can be divided by 1 and themselves. This is the factor of it. So 1 is neither prime nor neither prime or something nor composite. So what are the prime numbers? Are, you see here, 2, 3, 5, 7, 11, 13, 17. It keeps on going. Okay. So these are the prime numbers. This is the basic of this. So how many prime numbers can be obtained using all the digits of 1, 2, 3, 4, 5 without repetition of digits? So that is, you have to form 5 numbers. Okay. You have to form 5 numbers. Sorry, 5. You have to use 5 digits for forming these numbers. There are so many combinations of numbers which are possible, and you have to choose only prime numbers from this combination. But now come to this fact that add all these things. Okay, if you add all these things, it is coming 339. Okay, 339. So it's again divisible by 3. If a number is divisible by 3, it's not a prime number. Okay, a number is a prime number only when it is, see, you can form how many numbers ever possible, but it is not divisible by, sorry, it is not a prime number. That is because it is actually divisible by 3. If it is not divisible by 3, it can form a prime number. But here you have been given a set of number. When you add whichever way possible, it's not going to be a number which is prime. So the answer is 0. Okay, how many numbers can be formed? You cannot form any numbers. You can form many combinations of numbers with the digits which have been given to you. But those numbers, when you are forming as a non-repetitive number, like the chart, which you can put the chart like this, the chart which you can put a huge chart like this as a combination of numbers, and you can try to find numbers where it is a prime. It will not be possible because all these numbers add up to 3. 3, when you are adding up to 3, it is divisible by 3. If it is divisible by 3, it's not a prime number. The answer is 0. So this is the thing which I was talking about, and I think we have solved some questions. I will again go back and revisit CSAT and maybe solve some more questions which are relevant for this examination. This form, or this permutation and combination, as I have been saying, look at this question paper from 2020 at least. This question paper or previous year question paper solution and their analysis will take you a long distance in clearing the cutoff. Don't worry about clearing, the too much worrying about something will not, cross you the cutoff. Rather work on them. Like you go with one thing, we'll solve one thing. There are some more things. Already, I think I've solved syllogism. For syllogism also, we have a video. You can look at the basics of syllogism. Also, I'll maybe put the link in the description. You can check that and try to clear the cutoff. And any other doubt you may have, you can put it in the group also. And there is a Minds of Aspirant. There is a group, Telegram group. You can put the doubts there also. Maybe I'll solve some more as the prelims goes by or nears by. I'll solve some more questions. Thank you. All the best.